Our lesson today is to be able to add and subtract algebraic expressions. We're going to start off with some models, just to get an idea of what's happening visually when we add and subtract algebraic expressions. First, we need a key. A green rectangle is going to be represent a variable. So one green rectangle represents 1x. One rectangle would represent the opposite of x, or negative 1x. And then we have our zero pair, which would be a green rectangle and a red rectangle put together. We have a yellow square representing positive 1, red square representing negative 1, and once again you can make a zero pair when you have opposites. Alright, so let's first start by writing some expressions that are represented by some of these some of the models. All right. Now this first one I see, or example A, I see an x. I see one green rectangle which represents x. I see three yellow squares which represents 3. So one green rectangle and 3 yellow squares represents the expression x plus 3. In example B, we have 2 green rectangles, so that's 2 x's. We have 2 red squares, that's negative 2. So 2x plus negative 2, or 2x minus 2, is represented by example B. Example C, that expression, I see 2 x's, and I see 2 zero pairs here, right? So a positive 1 and a negative 1 cancel each other out. That's a zero pair. So I have another zero pair here, but I still have 3 left over. So that's going to be plus 3. So 2x plus 3 would be the expression represented by that model. Here I have how many zero pairs here? 1 zero pair, 2 zero pairs, 3 zero pairs. So I want to get rid of my zero pairs, but I still have 3 x's. And I still have 1, 2, 3, 4 negatives. So 3x minus 4 would be the expression represented by that model. Okay, well, let's use the models now to add expressions, now that we know how to write the algebraic expression for the model. So here we have 1x plus 2, and I want to add to that 1x plus 4. So when we use the models, we actually put the model pieces together. So I have 1x here and 1x here. That's going to be equal to 2 x's. Then I have 1, 2, 3, 4, 5, 6 positive 1s. So that's going to be plus 6. So 2x plus 6 would be the sum of x plus 2 and x plus 4. Let's look at our next example. This is going to be x, 1, 2, 3, 4, 5 minus 5. And this second expression is going to be x minus 2. I want to put the two expressions together, right? So I'm going to have 2 x's, but then I'm going to have 1, 2, 3, 4, 5, 6, 7 negatives. So 2x minus 7 would be the expression, the sum of x minus 5 and x minus 2. Let's look at our next example. We have x. Then I have 1, 2, 3, 4, 5, x plus 5 here, plus parentheses x minus 3. Now here, we're going to have some zero pairs because I have a positive 1 and a negative 1 here. So I want to get rid of my zero pair. So I take one positive and one negative, cross them out. Take another positive, another negative, cross them out. Another positive and another negative, cross them out. Now I'm ready to look at my sum. I have 3 x's in total. Then I have 1, 2 positive 1s, so 3x plus 2 would be the sum. Here I have 1, 2, 2 x's, 1, 2, 3, 4, 5, 6, 7, 8, so that's 2x, 2x minus 8. I mean 2x minus 8. And then we have plus, this is 3 x's, plus 5. Once again, you're going to have some zero pairs because I have opposites. So I'm going to undo those opposites. A negative 1 and a positive 1 is a 0 pair. There's another 0 pair, another 0 pair, another 0 pair, another 0 pair. So I'm still left with 1, 2, 3, 4, 5 x's. And then I'm left with 3 negative 1s, so that's going to be 5x minus 3. So that's what it would look like using the models to represent the addition of your algebraic expressions. Let's do a few subtractions, right? A little different with the subtraction. So I'm going to have 1x here plus 3. But now I'm taking away one of those x's and 1. Right? So to take away, we do this. Right? If I have to take away 1x and 1, I'm going to circle 1x, take that away, but just by drawing the arrow, and take that away, right? So I'm taking away an x and a 1. So once I take them away, well, what's left from my original parenthesis? And from my original parenthesis, I just have 2. So the difference between x plus 3 and x plus 1, the difference there is going to be 2. Okay, let's look at the next example. This is 1x minus 4. But now I need to take away 1x minus 3. So I'm going to circle that and take that away, right? 1x minus 3, I'm going to take away 1x minus 3, and I'm going to be left with negative 1. Right? I just have one negative left over there. So the difference between x minus 4 and x minus 3 is going to be negative 1. Let's look at the next one. This is going to be 2x plus 1, 2, 3, 4, 5. But I'm taking away 1x minus 1. Well, I have the 1x that I could take away, right? I have that. So, but I don't have the negative 1 to take away. There are no negative 1s in this parenthesis to take away. So what do I have to do here? Well, what I do is I add a 0 pair. So I add a positive and a negative, positive 1 and negative 1, which is a 0 pair. Now that I've added that 0 pair, right, I haven't changed my original expression, because if I add 0 to anything, I don't change the value, but now I have a negative 1 to take away. So I'm going to take that negative 1 away, and I'm left with what? Well, I still have 1x, I still have 1, 2, 3, 4, 5. So x plus 5 would be the difference. Okay, next example. We have 3 x's. Let's change colors. Right, we have 3 x's minus 1, 2, 3, 4, 5, 6, 7. But now I want to take away 2 x's plus 3. Well, once again, I don't have any positive tiles to take away. I only have negative tiles here, so I'm going to have to add 3 0 pairs. Right, 1, 2, 3. Right, so I add 3 positives, but I also have to add their opposites if I'm adding 0 pairs. So the 3 negatives, but now I have 3 positives to take away, so I'm going to take them away. Well, what's left? Well, I still can take away my 2 x's, so let's take away the 2 x's. Don't want to forget that. So what's left? I have 1x and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 10 negatives. So x minus 10 would be the difference. All right, so that's how you would use the models to do the addition and subtraction. Let's do some examples now without the models. All right, so let's go down here and take a look at a typical addition of an expression problem. So your first step, what I like for my students to do, if we have no distributive property, right? I have a parenthesis here, plus I have another expression here. So x minus 2, add 3x plus 8. If I have no distributive property, step 1, remove the parentheses. So this would be x minus 2 plus 3x plus 8. Step 1, remove the parentheses. Step 2, identify your like terms. I have 1x and 3x is here. All right, I have negative 2, positive 8 here. Step 3, put your like terms together using parentheses. You want to group your like terms together. So I have an x plus 3x, plus I have a negative 2, plus 8. Once you put your like terms together, next step, you simplify. 1x plus 3x is 4x's, plus negative 2 plus 8 is 6. So 4x plus 6 would be the sum of x minus 2 and 3x plus 8. Let's try another one, but I'm going to move this over here. First step, there's no distributive property, so I remove the parentheses. So that's going to be, I'll remove the parentheses here. So we have negative 4y plus 3 plus 11y minus 5. Step number 2, identify your like terms. I have my y terms, and then I have my constants. Next, we want to put our like terms together using parentheses. So I have negative 4y plus 11y plus, I have 3 plus negative 5. 3 plus negative 5. Negative 4y plus 11y, that's 7y. Plus 3 plus negative 5, that's going to be negative 2. So I can write my answer as 7y plus negative 2, or I can write it as 7y minus 2, right? Either one of those answers is acceptable. All right? Well, let's pretend for a second we do have the distributive property. All right? So if we have the distributive property, let's see what we're going to do with that. So I'm going to take a look at these couple of problems here. Right, examples E and F, where we do have the distributive property with addition. Right, what's that going to look like? Well, that's going to look like the following. All right, step number 1, when you have the distributive property, is to do the multiplication step. So we have to multiply 6 times x and 6 times 7. So I do that. 6 times x is 6x. 6 times 7 is 42. Right, I have no distributive property here, so I just remove the parentheses. X plus 3. Right, and then once we do that step, we go back to the same process we were doing for the other two examples. Identify your like terms. All right. Once we identify our like terms, we then group the like terms using parentheses. 6x plus x in one parenthesis, plus 42 plus 3 in the other parenthesis. 6x plus 1x is 7x, plus 42 plus 3 is 45. So we wind up with 7x plus 45 as our answer. All right, let's try the next example. This first parenthesis here, right, I have no distributive property, so I remove the parentheses. 12x plus 19. Here, I do have the distributive property, so I have to do that multiplication. 2 times x is 2x. 2 times 10 is 20. Now, no more parentheses. We underline our like terms. So I have 12x and 2x. Then I have positive 19 and negative 20. Let's group those like terms using parentheses. 12x plus 2x. And then we have plus 19 minus 20. 12x and 2x is 14x. Plus, well, what's 19 take away 20? That's negative 1. So I can write it as 14x plus negative 1 or 14x minus 1. Right? Either answer is acceptable. All right? So if we're using the distributive property, if you recognize that, we have to do that first, and then we go back into the same steps that we're using. Remove the parentheses, identify the like terms, group the like terms using parentheses, and then we simplify. All right? Okay, well, what does it look like when we have to do some subtraction? Well, let's do some subtraction. When we subtract algebraic expressions, we just have to add one more step. And that one more step is using the additive inverse, which means we want to change the subtraction problem to an addition problem and then just follow our steps that we use for addition. Well, how do we use the additive inverse when we're adding algebraic expressions? Well, here we change the subtraction sign to an addition sign, but because we have two terms that are grouped together in a parentheses that follow that initial subtraction sign, each of those terms in the parentheses has to be changed to its opposite. So this is a negative 1x, so we have to change that to its opposite. This is a positive 6, we have to change that to its opposite. Once we do that, then we follow the same steps that we did for the other problems. So next step, I have no distributive property here, so I remove the parentheses. So this is 5x plus 6 plus 1x minus 6, or plus negative 6 if you want to write it that way. Now we underline our like terms. 5x and 1x, right? We group them together, 5x and 1x, and then we group together the 6 and the negative 6. And then we simplify. 5x and 1x is 6x. Positive 6 and negative 6 is 0. So you can write 6x plus 0, but just writing it as 6x would actually be a bit better. All right? Well, what happens if we have the distributive property and we're subtracting? That's where it gets a little bit more interesting, because now you can do the problem a lot of different ways. You know, you put 5 different teachers in a room, they'll show you 5 different ways to do it. This is the way I've always done it, and this is what I like for my students to do. When you see the subtraction sign in front of a number that has to be multiplied using the distributive property, you treat that value that you have to multiply as if it were a negative. All right. So first, recopy this parenthesis, right, or remove the parentheses, 7y plus 5, right? Let's get rid of that. But now we have to multiply using the distributive property. I treat this as if it's negative 2 times 4y, that's negative 8y, and then this becomes negative 2 times, I treat this as negative 3 because of the minus sign here. Negative 2 times negative 3 is positive 6. All right, and then once we do that little step, right, we go back to the same process we've been using. Identify your like terms. Right, group your like terms using parentheses. 7y minus 8y. Then we have plus. This is 5 plus 6. 7y minus 8y is negative 1y. 5 plus 6 is 11. Right, there's your simplified expression. All right. All right, we'll do a couple more subtractions. Let's say, do we have any with the distributive property? We don't have any more with the distributive property, so let's do these. All right, since we'll do a couple more. So this first one here, I don't have the distributive property, but I do see its subtraction, and that's when we have to use the additive inverse. So I change the subtraction sign to addition sign. Now each of these terms in the parentheses has to become their opposites. 5x becomes its opposite, negative 5x. We treat this as if it were a negative 4. We make that positive 4. And now we have a regular addition problem. We remove the parentheses. 3x minus 2 plus, this is going to be negative 5x plus 4. Then we identify our like terms, group our like terms, 3x plus negative 5x, and then we have plus, what do we have, negative 2 plus 4. 3x and negative 5x is negative 2x, plus negative 2 and 4 is going to be positive 2. So negative 2x plus 2 would be our answer. All right, and we'll make this the last example. All right, once again, I see that I'm distributing, or I have a subtraction problem, so we have to use the additive inverse. So I add the opposite of each of the terms in the parenthesis. We change the subtraction sign to an addition sign, and we make this negative 2x to its opposite, positive 2x. We make this positive 2 to its opposite, which is negative 2. Notice that we never change signs in that first expression, right? Please don't make that mistake. Now we have an addition problem, and we remove our parentheses. 4x minus 4 plus, what's that, 2x minus 2. Next, identify the terms that are like terms. Next, we group our like terms. 4x plus 2x plus negative 4 plus the negative 2. 4x and 2x is 6x. Negative 4 and negative 2, right? That's going to be negative 6. So 6x minus 6 would be our answer. All right. I think that's going to be it. I think that's enough examples. And I want to see if I had another distributive property with the negative, but I don't believe I do. So we'll stop there, and I hope that that is going to be helpful for you guys. Take care.